Okay, let's verify the derivative first off, and I would rewrite it. Let's rewrite this as x minus 1 to the 1/3 power times x minus 2 to the 2/3 power. The domain of this is all real numbers. Let's go for the derivative. And let's see. Let's say the derivative of the first, which is going to be 1/3 x minus 1. I take 1 from 1/3, so minus 2/3, times x minus 2 to the 2/3 plus the first function, x minus 1 to the 1/3, times the derivative of the second function, which is 2/3 x minus 2, and then we would get minus 1/3. All right, what I'm going to do is going to factor the problem. And the first thing I want to factor out is the fraction 1/3. I'm also going to factor out an x minus 1 to the minus 2/3, and I'm going to factor out an x minus 2 to the minus 1/3. And what's left over? Let's take a look. You're going to get x minus 2 to the first power plus 2. And let's see, you would get x minus 1. Let me make sure of that. Yeah. And then that looks good. All right. I'm going to continue to rewrite it. And to do that, again, get this thing over here. I see a 3. I do see a cube root on the bottom now. What I'm looking at? I'm looking at this stuff over here. I see a cube root of x minus 1 squared and an x minus 2. And now I'm going to be looking at this part over here. And this does not look too bad to write down. What's that going to be? X plus 2x, which is 3x, minus 2 minus 2, which is minus 4. All right, let's see if we got the same derivative they got. And did we get the same thing? I got this. And I got this, I believe. Yeah, it's looking good. So what we're going to do now, put the critical numbers down. And critical numbers are where this thing is 0. And this becomes 0 at 4/3. And where's it undefined? It's undefined where it divides by 0 at 1 and at 2. Let's do some simple sign analysis over here and see what's going on. Now, if you take a number below 1, like 0, right, this is a test point, you get negative on top. And if you took 0 on the bottom, let's see, you get negative on bottom, so it's positive. What does that mean? It's increasing. Now let's go between 1 and 4/3. And a good number to choose there, 4/3 is 1.333. Let's pick 1.1, all right? I'm picking 1.1 as a test point. So what do you get on top? You get negative. And what do you get on bottom? If you took 1.1, you still get negative. Overall, it's positive. Okay? What happens between 4/3 and 2? Well, I'm going to take another test point. And the test point I'm going to pick is 1.5. If I put 1.5 on top, what do you get? Well, you get positive on top. And on bottom, what do you get? Well, you get negative. That means it's decreasing. After 2, pick another test point. I don't know, like 3 or so. What do you get? Positive on top, and you get positive on bottom, so positive overall. All right, so the critical numbers are 1, 4/3, and 2. Let's see if they're written down. 1, 4/3, and 2. I got those written down. Simple sign analysis, well, I did that. Indicates I got a local maximum at 4/3. Let's see if it says that. Local maximum at 4/3. And again, looking at my little diagram over here, my local minimum's at 2. And what's going on at 1? There's actually a vertical tangent there. Of course, I really emphasize that you really should be looking at a graph. And I know these graphs are hard to construct, but if you have a machine, the machine can construct it pretty rapidly. And I want to look at this. I want to look at these values that we're getting. And I want to point out the values that we're looking at. We're looking at the critical number 1. Remember, so we got a vertical tangent there. We're looking at a critical point 2, and we said we had a local minimum there. And 4/3, right about here, is where the local maximum is. And this certainly fits the description of what we've given you. All right, what I mean by that is, we took the derivative, we did our analysis. This visual certainly reaffirms our belief in what we just did. Thank you for paying attention.